And this is basically, if you understand chapter 14 well, this is not going to be a big of a problem. There aren't so many new stuff here compared to what we covered, and it's actually going to be more straightforward. And there will be no manual calculations at all. So it's going to be a lot of Excel work most of the time, I would say. So we're talking here about multiple regression analysis. And that's the case when we have more than one independent variable in the model. So we're going to talk about how to develop them, which is pretty much the same procedure that we followed in chapter 14. And then we're going to read the same and interpret the same summary results again and try to see an U important measure, which is the adjusted R square that we haven't gone through properly with a simple linear regression. In this kind of regression, we don't have a graphical demonstration because that takes us from 2 dimension to 3, 4, 5, depending on how many variables we have. And let me see if I hope that if Nada can mute herself. That would be nice. Um, so yeah, and then we'll have the inferences about the independent variables, and this is very important, and we have questions about this in the final. So given what you see from a coefficient perspective, how do you interpret that, and what does it mean? It's just not like you only have the equation and that's it. You have to understand what that means. And then we will also have one of the most important thing concerning regression modeling, which is the qualitative independent variable. So if you have a list of categories, how can you capture them given that they are qualitative labels? This cannot be quantified. But there is what we call binary coding or categorical coding. So you'll learn that. And then finally, we're going to end up with strategies concerning model building. We're going to have these stepwise and the best subset. And there are a couple more, but the most common ones that are used are these two. After that, we're going to revisit the quality check we do for regression model, and that's going to be the final topic in this chapter and in this course in general. Of course, I'm going to be coming back and forth with visiting the Excel examples that I think you have access to on Moodle. So if you want to follow along and you want to work on that, just feel free to download that and be ready to apply whatever that I'm applying. I'm going to start with the fact that this is exactly chapter 4. The only difference here is that instead of having y hat equals the intercept and slope, now we have several slopes, or let's say coefficients in this case, because we don't have a graphical representation in from a two-dimensional perspective here. So we have y hat beta or b0 here plus b1, b2. So here we can add as many independent variables as possible. That's the only difference. And it doesn't have any severe implications when it comes to what we predict. The only difference is going to be that we're going to look at the adjusted R square. And then we have, of course, the modeling dimension. So we will learn how many variables are enough, and sometimes we might add variables that will backfire and that are actually not good to have in our model. So basically, we're going to keep adding models that we have data on and we believe that they're relevant, but some models, some variables, independent variables might have collinearity or what you call multi-collinearity. So they are correlated with each other, and having them both at the same time can be a problem because, well, one captures two variables that capture the same thing pretty much, and they can create noise to each other. and make it sound or look like as if they explain more variability than they actually do. And that's where we do that final check. All right, now, without further ado, let's just take the first example. And in this example, you have access to that. I'm going to be switching between examples here, and I think my example should be, in this case, this one right here. So we have cars, 20 cars, and in these 20 cars, there's a price attached to each car. So this is basically that if you look at any platform where they sell cars, you just went there and collected data about the price, the asked price, mileage, so how many kilometers or miles the car has gone, and then the car's age. For this one, you can basically for now ignore it. So I'm going to actually go ahead and delete it. Um, Now, if we want to, well, let's not delete it. Let's actually hide it for now. We're not going to use it now. We want to predict the price of a car just based on mileage and car's age. So with a simple linear regression, we only had one independent variable. In this case, we have two, all right? So the basic drill for this is, again, data analysis, and then we go to regression. Click OK. And then basically, what is it that we want to predict? We want to predict the price, right? And then since we highlighted the label, we need to check that. Then how many variables do we want to include in our regression model? These are called the predictors. So we use mileage and car's age to predict the price of a car. Okay, we try to infer that from here, and then I'm going to check this location right here, and then click OK. Now, I added this bar just for explanation, but we can just stop here and see.
Doctor, can you
What
just
do you
repeat
think
this
this is
step again?
different? Yes.
Can you just repeat this step one more time?
Have you attended any of the previous?
Yes.
Yeah. So this just not to make this video very long. This is recorded. You can go back to the recording and repeat that. But we did this twice or three times before, and this is data analysis, regression, and then for the Y, you highlight Y. For the X, you highlight mileage and cars.
Okay, I got it.
Got it?
Yes, thank you, sir.
Just for you to know that this is being recorded right now, so you can come back to that. And if you miss any piece of detail, just do that. I don't want to make this video long. That's all. All right. So what we can see here, if I may ask any of those who are here, what's different between what we generated before concerning the summary output and this one? What is so different? Anyone?
We have an extra slope. So we usually had two.
Yeah. We used to have one,
Yeah,
and now
like
we have two.
intercept and another one. Like intercept and a slope. Now we have intercept and two slopes.
Now we have mileage, and we also have car's age. So this is what makes a simple linear regression model a multi-regression model, just by adding another one. Now we have two variables. So basically what we're saying is, if we want to predict any car, let's say According to this, if we say, I think this cell references these values, yeah. So maybe it will, yeah. So it's going to be, and the price, which is y hat, it's going to equal intercept. So it's this number. So what we're saying here is that $28,000. This is, by the way, these are the used Camrys. So any used Camry you want to buy, it's going to start from $28,000. And then the value of that will decrease. You see the minus here? This means it will decrease depending on the mileage and the car's age. So say that it hasn't gone any kilometer, or in this case, mile. So if you add 1 mile, it will depreciate. It will go down. The price of that car is going to go down by $0.14. So if you add more, let's say that we want to predict a value of a car that has gone, let's say 50, let's say mileage here, mileage, let's say 50,000 miles, and the car's age, let's say it's 10 years old. The car's age is 10 years old. Say 10 years old, and this is miles, just for demonstration. How would we use this? Well, very simple. It's going to be the implementation of this. It's going to be intercept, the $28,000. This is starting. Doesn't matter. It will start from that price. And it's going to go down by this number times 50,000 plus this number times 10 years. So we expect the price of that kind of Camry to be 11,274. And that's how you generated that. But then we're gonna look into the same things that we looked at in the past. So before I proceed, do you have any questions here? All right.
Huh.
Yes.
Sorry, I wasn't following up. I joined a bit late, so I understood everything except for the 50,000 miles and the 10 years old. Can you tell me just where did we get that exactly from?
No, this is just an example. Let's say that you saw a car that like it's ad. There is an ad about a car where the person of that car, let's say, asks for $15,000. Okay. And what you did is that you took, let's make that $1 here.
So it depends. It comes like from the question, right? So it depends on the example.
This is a given, yeah. This is a given.
Oh,
Just to make
okay,
it
okay,
clear,
okay.
this is a given, yeah. So that person did that, and you checked the car's mileage and the car's age, and you said, you know what? I'm going to look at previous Camrys and generate a regression model. And using the coefficients, you predicted that the actual price, according to your model, it's actually 11,000. And this person is asking, this is an overpriced car in this case. All right. Does that answer your question?
Yeah, doctor, that explains it. Thank you so much.
All right. Now, once we do this, that's it. No manual calculations. You don't need any of this. And the example is in Moodle. We're going to talk about pH stat later. But for this chapter, it's just Excel, basically. That's all. And if I want to go back to the coefficients here, and as explained, this is going to be very important in the exam. And by the way, the exam is finished. So I know exactly what's going to be there. That's what I'm saying. And there are all the versions are finished and done, and you will have some of this in the nested questions, just to understand what minus here means. And in this case, we have a car that has gone, depending on how the mileage and depending on the age of that car, how can we interpret those coefficients? So if you talk about the car mileage, the intercept here says that, well, before adding the factors of the car mileage and the age, the price starts from 28,000 for any used Camry. Okay, assuming zero car mileage, zero car age. So it's pretty new without any adding. But that's a used car. I mean, it's used, but it's zero, but this is just hypothetical. All right. Now, if you want to add this price is going to go down now because we have a minus. It's going to go down for every single mile the car has gone, according to this regression model. And the same thing is going to apply to the year. So for each year, the price that you ask for a used Camry is going to go down by $986 roughly. All right, this is how you interpret those minuses. And if this is a positive relationship, you're going to say, well, actually, the price is going to increase for each unit of that variable. But that's an opposite scenario. So that's just that you understand this, because we have questions about that. So we might also add another. So let's say if we go back. No, we have that already here. Yes. And that's exactly what I'm talking about. Yeah. Yeah. Now, we have to do the same quality check that we did before. Before I get to that, there is what I believe is the most complex part of this chapter is calculating confidence interval and prediction interval. The video that you have on Moodle is dedicated to that. I just don't want to waste any of the time here. It's going to take me forever actually to go through it step by step. So I have that video for your review. And there's also a template that you can work with to apply whatever that is shown or demonstrated on that video, right? Confidence interval and prediction interval, it's much more complicated than what we did before. But that's unfortunately there is up until now there is no software that can do that for you. Otherwise, I would have used that, as you know. But this is associated with an estimate. So say the same Camry that you estimated, how confident are you about the 11,000? So the 11,000 that we generated here, can we go a confidence interval and a prediction interval around this estimate? Yes, we should create that, but how confident are we? That reflects basically the confidence interval. There's a prediction interval. So the prediction interval is going to be wider every time. And that's how you that's the most difficult part, I would say, in this chapter. So I'll leave that for you guys. And I'll move to the next part. I mean, we've talked about this before. There are residuals, residual and regression and the total. So the total sum square, that's the one. And then the sum square error and the sum square regression. Now, these are the corresponding ones are SS, then sum square. Now, SSR divided by SST, that equals R square. Just for you to know how did we calculate R square? And if any of you remembers what R square means, do you dare to say how you understand R square? Coefficient of determination?
Is it the
No
p
more.
value?
R square, this one right here.
Yeah, is it the p value?
No, that's significance is the p-value. So how much, in this case, how much do mileage and age explain the variation in price? If I ask you, you want to buy a car, used car, if we know the age and the mileage of that car, is that enough to explain it? You can say, yes, that's enough to 55%. That's what that means, okay? We can explain the price and the variation in prices 55% based on our data. That's what the coefficient of determination is. Maybe if we add another variable, we'll understand more. That's going to be probably 65% or so. Do you get that? Please, now is the time to ask questions if you still need explanation, if you need me to go into this more. But R-square is basically one of the most important measures for regression. The first thing that you might get as a question, what's your R-square? My R-square is 55%. This means that my regression model can, to a great extent, predict variations in the dependent variable. So if I want to predict what the dependent variable is, I'm going to be 55%, let's say, accurate. All right. Now, moving to the p-value. We talked about this before, and we said that when we had this as a single linear regression, it was basically the same as the slopes p-value. But now things are different. Now we have several ones, and for each one we have its own p-value. Like if you look at the intercept, mileage, and age, they all have their own unique p-values, and this is for the regression, for them all together. So if we have this as small as you can see here, then our regression is credible. So we have it less than 5% if we assume alpha as 5%. Then we can say that, well, this is very small and it's a significant. These numbers are significant. Okay. And if you recall the hypothesis testing that we did before, that should be fine here too. Now, moving on to the adjusted R-square. This is very important, and this is the formula for it. And you don't need to calculate it. You have it on the summary of results. But if I go back here, now the R-square is always going to be inflated if I add more and more and more independent variables to the model. It's always going to increase. It will never go down. And that's a problem because sometimes you add not really important variables and you still get answers as if they are, still get results as if they are important, like by an increased R-square. And that gives you a false sense of accuracy, which is not really the case. So for that reason, they developed this adjusted R-square as a heuristic. And heuristic means like an approximation. So we said, like, if we add more, this can go up and can go down too. So if you add more independent variables, it won't only just go up constantly, but it can also get affected negatively, which gives us more accuracy in that case. And we want this because sometimes you add independent variables, but the adjusted R-square is going to be less, all right? We want to know that, well, what we added right now, it wasn't actually relevant. And we can test that using our example here. So if we add now the seller's age, so we're saying, can we predict the price using the seller's age? Well, as you can see, apparently it's not relevant. So it doesn't matter who or how old that person that sells you the car, doesn't seem to be very relevant to the price. But if we add it, let's do that data analysis again, regression. And now we want to include it in the x-axis. So we want actually all these three as our independent variables. So if we, let's say we want to put that right here, click OK. Now, if we look at the R square, has it, I mean, comparing, I'm gonna need to bring this here, just I want you to look at it and see. Did it actually increase the R square? So this is the new one. Is this higher than this one? If you're focusing, if you're not,
Not much.
No, but it increased. It increased. This 0.555, 55%, 0.5 is higher than 55.24, 0.27. If I ask you, should I take this model or this model, you will tell me, yeah, no, based on R square, we should take the one that is more accurate, the one that can predict the variation in the price with a higher R square, right? Which is the one that has the seller's age, right? Would you do this? I mean, are you guys following?
Yes, doctor.
Anyone? You can also chat if you don't feel like you want to talk. Now, if you look at the adjusted R square, it got negatively affected. So if you look at the adjusted R square of our original model with only the mileage and car age, it's higher than the one that has the seller's age on top of the car's age and mileage. And that makes sense because, well, what would the seller's age have to do with the sales or the price, logically speaking, right? So you expect that to be logical, that the adjusted R square is less. And that's why we look actually at the adjusted R square in multi-regression analysis. For single linear regression, yes, that's fine. You can actually look at that. But for multiple, you only want to look at the adjusted R square when you want to compare between models. Is that reasonable? Does it make any sense?
Yes, doctor.
All right. Now, moving on. So our regression is significant. Our R squared looks like this, 55%. Is there anything else that we need to check? Do you remember that from the previous chapter? What else should we consider? We should look at the significance of each one of these variables, the intercept, mileage, and age, right? No
Yes.
one's, yeah. And how do we do that? Any suggestion?
Comparing the p-value.
Yeah. So looking at the p-value right here, this is very small. It's like we have 8 zeros. So this is obviously significant. Now looking at this one, it's also significant. And this one is also significant. So all of them are less than 5%. So if that's our alpha, then we basically reject the null hypothesis that there is a difference. There's no difference, I'm sorry. And we say that, yes, all of them are significant, so they're credible. Okay? Now, if I want to go back to that model that I generated with the seller's age, if you look at this, Are all of them significant?
No, the seller age is not.
So here you can see that this is 77%. The p-value is so high. This is a probability, 77% probability that the seller's age value, the coefficient here, can be 0. 77%, this value can be 0. That's pretty high, right? So if you look at the confidence interval, you'll see that it actually hovers between minus and plus. So 0 is within this interval. Both, well, in this case, I have 2 as 95%. So 0 is included, and p-value is really high. So there is no need to question or second thought this. This seller's age should be removed from the model, right? Is that something I should do you think? When I say I should remove it from the model, all I mean is that just whatever that I have as a data here, when I included the x's, so when I did the data analysis and regression, whatever I did here, this, when I remove this one, basically don't include it. That's all. That's all what I mean with removing it from the model. Just don't include it. It's not relevant. It's not good. All right? And that's the adjusted R square. And
So doctors, we don't include the seller's age.
seller's age. And how did we know that? First, the adjusted R square was less compared to the model with only the car's age and mileage. When we added a third one, and that was the seller's age, it became less. So that's the first indication. The second indication was, as you can see here, the p-value here is so high, it's more than 5%, right? And then if you look at the again, that's as additional evidence, the confidence interval includes 0. So there is a probability that this coefficient is 0, and this 21 that you can see here is just a variation that came out of that, which means that the seller's age as a variable is probably not important. Okay.
Okay, thank you.
Now, let's get to what increase the level of difficulty a little bit in modeling. Sometimes you have the data and it's all quantitative, and that's good, easy. It's called numerical data, right? But sometimes you don't have that really. You have categories. So if you switch to the second sheet here, you will see that, well, this is an example about if you have your salespeople in real estate companies, if you have them as male or female, whenever you had a male person, the earnings were this number, female, the earning was a different number, and so on. So how would we predict the earnings given the gender and the years of experience of that salesperson? What do you think? I just want to hear your thoughts here. How would we, well, whenever I include this, if I go to data, let's do that and show you what would happen. So if I wanted, what is it that I'm going to predict? Earnings, right? So this is our Y variable. Our X's are going to be years of experience and gender, right? And let's say that I want to print the results here. What would I get? I would get an error. Input range contains non-numeric data, and that's because of gender. These are not numbers. This is text. And I need numbers, and regression only works with numbers. What should I do? Any thoughts? What do you think? Should I just abandon gender as input, or can I make use of that somehow?
I don't know. Is there a way to do it on Excel or?
Yeah, there is a way,
Like-
of course. Otherwise, I'm not going to talk about it, right?
I think
Yes.
we use pivot table.
You will what? Again, sorry?
Pivot table.
Pivot table. Any other inputs? All right. How about we code them? We use what we call binary coding. So what we say, if this is a male, for instance, we're going to call this, let's cut and paste it here. And
So
I'm going,
0 and 1.
what I'm going to call here is going to be called dummy variable. Dummy variable means like a variable with codes that represent the category. So let's call this, when you have category of 2, you have 1. It's always less by 1. We're going to have another example just to show it to you. But I only need one variable to show the two possible categories. I'm going to call this dummy variable. And since we only have two categories, it's going to be dummy variable 1. Variable 1. And what does it actually mean? It means that I can only add zeros and ones depending on the applicability of that category. So if it's male, let's say we assume that if it's male, it's going to be 1. If it's female, it's going to be 0. Okay? So here's the application of that. I want to say, well, if this number right here equals male between quotation, consider it, put the value of 1, otherwise set it to 0. Okay? And I'll scroll down right there and see. So we can confirm and see that, well, actually, all of them, when we had, it was 1 for males and 0 for females. So there is no problem so far. Now, if I want to go back to data and regression, I want to highlight earnings again. Now I can highlight, instead of the gender with text, I can highlight the numbers. And let's select this cell and go ahead. Now we have the dummy variable in our analysis, and it means minus. What does that actually mean? When we have male, the earnings will actually decrease. The earnings will decrease by 2.8 because that's going to be 1. If it's a male, here's how our regression equation looks like. We've got the intercept, so y hat equals the intercept, which is B0, and that is, in our case, it's actually 47. Let's approximate that, plus the years of experience. For each additional years of experience, the earning will increase by 1.35. And that's times the years of experience, and then minus, now we have minus 2.84, depending on the male, if it's male. If it's male, this is gonna be 1, okay? This is gonna equal 1 because we used 1 to denote male. All right? Do you get this, or do you want me to, people sometimes struggle with this coding.
Doctor, I do, but won't the variables, like the dummy variables, affect the calculation? So let's say if we used other numbers than 1
So
and 0.
let's say that this is a female. If it's female, what would happen? It equals 0, right? If it's female, we don't have this minus. It's gonna be times 0, right? We don't have this value at all. So the impact of females has been factored already by these calculations.
Okay.
You see?
So it's all gonna be 0 if it's female.
Not all of it, just this part that has
Yeah, the one
that's
on the right.
captured by the dummy. Yeah. So it's going to be only because what this data suggests is that we actually the earnings are going to be higher if it's a female, but if there is a if there is if that was a male, it will be reduced by this factor, because that's going to be 1 in this case.
Yeah. Okay. Okay.
You see? Now let's assume that we have 3 um, categories. So instead of saying male and female, we're gonna say something else than gender. Let's say
Age group maybe, or Gen
yeah,
Z
let's
or
say
Gen X or
yeah, we can.
Gen.
I mean, that's a good idea actually. Let's say if it's a generation, generation. So generation. So let's say this is boomers, baby boomers, and that's female could be millennials. Millennials. And then we can say this is Gen Z, right? Okay, and let's just basically put that wherever we find. Let's say millennials are here and here, and boomers are here, here. I know millennials is misspelled, but excuse me for that. Boomers, let's say Gen Z here, again here, and then millennials for the rest. I know you guys millennials, so you're not millennials, you're Gen Zs, right? You are.
Yeah.
I am the millennial here. Let me see here.
So doctor, how do we do it here? Is it like 0, 1, 2 or?
You're gonna see, you're gonna see. So how many dummy variables? That's the first question you should ask yourself. How many dummy variables do we have here?
Yeah, we would need 3 because we have 3 different categories.
We have 3 categories. We only need 3, not minus 1. It's always the number of categories minus 1. And you're gonna understand why. So when we had 2 categories, we used only 1 dummy variable. When we use 3 categories or 4, let's say 4 categories, we're gonna need 3 dummy variables. You're gonna understand it now. So if I take this and generate a new dummy variable,
So it's
let's
gonna
call
be
that
the
dummy variable
number
2.
number of categories minus 1 is how many variables we need.
Exactly. You're gonna understand why now in a moment. So let's say that if this is a boomer, it's going to be 0. Sorry, it's going to be 1. And the dummy variable, the second one's going to be 0. Okay. If this is a millennial, the first one that captures the boomers, it's going to be 0 because that's not a boomer, it's a millennial. And the second one is going to be 1. We just decide which category gets what. If this is a Gen Z, both of them are zeros. Okay? This way we have a numerical representation of the 3 categories, right?
Yes. Okay, so but we can also, like, let's say if we had 4 categories, we can do the same. Of both of them can be 1,
No,
right?
we never use 1 more than once.
Okay, okay.
So it's always going to be 1 because we want to factor the impact of the variable. So 1 should appear, and then we only have 1 variable, 1 category that is captured by the zeros.
Okay,
Okay?
okay.
So let's say that we want to do this here. How do we do it? Again, using, if we go back and say, well, if this category right here equals boomers, the value would be 1. otherwise 0. Now, for the second one, we're going to say if it's millennial, and millennial is not written correctly here, I'm sorry about it. If I'm just going to take the same spelling. If it's millennials, if this is millennial, has to be 1, otherwise 0. Scroll this down. You're supposed to capture millennials when you have to. Same here. You're going to capture. So whenever we have 2 zeros, that's Gen Z, Gen Z, Gen Z, right? And with that, we can repeat our analysis going back to data analysis, regression. And for the X part, we just want to increase that to have 2 dummy variables instead. And then we can regenerate it. And as you can see here now, actually, we have the impact of, we have 2 minuses. So if it's millennial or boomer, it's going to, so basically Gen Z sells more. That's what you can see here. Because when these are 2 zeros, that's when Gen Z applies, right? Then we have the intercept plus the years of experience. So if you are a Gen Z with the years of experience of 3, for instance, the earnings are going to be 46 plus 1.4 times 3 years experience, but then plus 0 and plus 0, because these only captures one of the other categories. If this is a boomer, it's going to take a dip. It's going to decrease by 5. Okay, whatever the number here is going to decrease by 5. So do you see how this applies? It's that actually activating the category whenever it applies, and there is a factor, and that factor, if it's positive, it's going to increase the overall value. If not, it's going to reduce it.
Yeah, doctor, but I have a question. So what if we did the same thing, like we gave 2 zeros, but for boomers? We would have different answers.
Interpretation. So if you change this and say like, wait, no, what? I want to make zeros as for boomers instead. Let's do that and see what we get.
Because
So
if we
if
want to
it's,
prove the generation, we have to try it for all, for each and every one, right?
no, you need to do it once. Just decide whatever digits that captures. I'm gonna show you how. But first, let me see. Let's say that you are a salesperson of 10 years of experience, and you are a baby boomer. So let's say that you are, in this case, you are 1, the dummy variable 1 is 1, equals 1. So the earning here would be predicted as the intercept plus this times 10 years plus baby boomers is the first one. Okay, that's 55. I don't know if that's millions or whatever. But if we change the coding, let's say we want to change the coding, we want boomers to be zeros instead. So millennials are going to take the first. So we're going to change this to boomers, from boomers to millennials. Okay. Now let's rerun the test. Data analysis. We're going to print them somewhere else. Now we have different coefficients, right? Well, we want the same configuration. We want the earning of 10 years for a boomer, but boomer this time is 0, right? It's all
Yes.
zeros. So it's going to be basically this times 1.3 times 10, right? And the others are zeros already.
Yeah.
It was slightly higher. depending on
So
how you code.
so see, the coding affects the final answer. That's why I'm asking.
Yes, it
Like
does.
in
It
the
does.
yeah, in the exam, like I don't know which one should which one
No,
should be
it will be.
zero, which one should be
It will be clear. It will be clear till it will still tell you. Assume this as the one that has zeros. This that one that
Oh, okay,
will
okay.
be specific. It will be specific. Don't
Because
worry.
if I choose like if I plug in any variable, I will have different answer, like different answers
Yeah,
depending on
yeah,
which
yeah,
one.
yeah,
So that's
absolutely,
why.
absolutely. But it will specify exactly what dummy variable you should that should take the zeros and which one should take ones and so on.
Okay, okay, okay.
And that's not
Because
only
that
for
was
you, also business analytics. They got this question, and the coding is specified by them. Still,
yeah, that
they've more than 80% missed that question. All right. So,
that
but
was my
they're not as prepared as you will be when you take that course, hopefully. So, I'm
inshallah.
counting on you guys. All right. Um, so that's the qualitative independent variable. This is how you capture categories, and it's called categorical variables, right? Um, and that's the example that I just showed you, and this is the interpretation of what you see here. And that's basically for whenever you have these two as zeros. Where was that? I think this one. We have this zero. So this as zero, it means that this is a female salesperson. And then we don't have this discount from the earning. Similar thing would be if you have what we have as zero is called the base category. Like if we want to see the sales over several seasons, spring, summer, fall, and you have also winter, then we have three dummy variables. Let's say spring, summer, and fall. And when you have all zeros, that's basically winter, right? This is called base category. So the exam will specify what would be the base category in this case.
Okay, okay.
All right. Now, this was the last point concerning this. And of course, we have to check the p-values and see that, well, all the p-values are below, like we can see here, for instance, that this one is pretty high. It's 50%, so it's actually not significant, and then we can see also the intercept being not significant. So even though that you can get values, and that's why if we look at what we generated right there, could be the same thing. If you look at the p-values here, we didn't get them in the first place. I don't know why, but if I look at this, for instance, see variable 2, the p-value is so high, 67%. So it's not really a reliable model. It's not a model that you would trust because this value can be pretty much zero. Okay. And that this one is also greater than alpha. So this coding did not obviously help in this case. And that's when we have two dummy variables. And that's because we faked this data. We faked this data set. It wasn't natural. It didn't come as we just made it up. Okay.
Yeah. So here, if we see this, we say okay, generations doesn't have to do with the uh earnings, and
Yeah,
you have
yeah,
to choose a
pretty
different
much, pretty
category. Yeah.
much, pretty much. And you can, uh, the more scientific way would be actually remove it, look at the numbers, years of experience impact without it, and then look at the adjusted R square and see if the adjusted R square goes down. If it goes down, then that's also another indication. But from the significance, you can see these can pretty much be zero. And they just can be removed from the system. They have nothing to do with the earnings in this case. Gender or generation does not affect. That's the conclusion. All right. So you're going to have that in the slides. I think you have it already. Just to see this, these interpretations are very important just to understand. And the questions there will be some multiple choice within the questions about this. So Yeah, you have to, you have to understand this part well. Let's come to pH stat. These are all the details that you needed to know about multiple linear regression. The biggest part, most complicated part was the prediction interval and confidence interval. But apart from that, we have the pH stat, and that's what you have access to. I said Canvas, that's because this was the older platform, but what you can do here is that just basically go over. This is paid. You have to pay to take it, but I kind of took it and I have it as a folder and I share it with my students. I don't care about the company. I don't know why they have it paid in the first case. In the first place, I'm sorry. So how do we download this? I think you can download it, download the folder. And once it's downloaded, I think you need to take this out. Take it out to, let's say, a desktop. And then you need to click on this pH stat. You can probably close this one. Open pH stat again. So go to document options, add-ins, and then go, and then browse. In the add-ins, you can browse. I have this, I'll have that in the slide, and I think it is already in the slides, showing how to download it, a pH stat, and then you can open it from here, and you click OK. This file type is not supported in protected view. Is this a protected view? Yes, probably the case. I probably need to. Let's open a new one and try to do that again. Options, add-ins, go, pH stat. Okay. I swear it works, but you might try it and it will work on your end. But I might have messed up the things that I have here because I have a lot of stuff, as you can see. Let me see here. I can go to desktop, pH stat, copy, and then back, paste, then okay. Yes. Okay. I need to unprotect the sheet. And from what I know, this is supposed to be done here. Review, unprotect. No. All right. Let me close this all over again. And then I'll go back to Word, no, Excel. Account. Second new one. Page stat. No, it has there's an issue here that I have to resolve. File name doesn't support being used by another program. We're trying to save is the same as the open. Yeah,
Look,
there's an issue. Yeah, please.
yeah, I tried the same thing. Protected view issue. I tried to unprotect it and protect it again. It still doesn't work.
Okay.
Maybe if there's an explanation in the PDFs
I
or
think it has to do with the trust center. I have to go to the trust center. Add-ins, trust center. I go here. a trust center. I did that many times before. Didn't used to be a problem. Trust center settings. And then I have to click the add-ins right there. Disable all applications. Click macro settings. Macro settings. Clear all the checks, macro settings, and the lift pane. Then I have to choose disable all macros with notification. Disable all macros with notifications. Yeah. And then I click OK. Let's see if that works now. No. Yes, I'm gonna get the hang of this later. We can proceed. It's not a big deal. Manage, browse, locate the extracted folder. I'm gonna resolve this and show you how it works. There's something on my end. Maybe the file is detected. This is a paid add-in. And actually, you're not gonna use it a lot, I would say. Just wanted to give you an idea of what it does. So you might be asking now, well, what would be the ideal way to build a model? Let's say that you have several independent variables and you want to say, okay, which of these variables I should include in my model and which I shouldn't, and what kind of combinations? Let's say that you have 7 independent variables. The number of combinations for how to combine them and get a model out of them is so high. Do you need to do this manually every single time that you put x1 and x2 and sometimes x1 alone and to compare all these combinations together? This is what phstat does. And I did it many times using this, and that's called model building. This is a model building strategy. For a model building strategy, sometimes the most 2 common ways of doing that, the first one is called stepwise. And stepwise basically means that you add one model and we add one variable and see if it's significant and if it has a high R square. If it's significant, you leave it and then you add another one. If that other one, after adding it, if R increases and adjusted R square increases and everything is significant, you keep it and then you add another. And after you do this, well, if something is wrong with that, the adjusted R square decreased, or if it's not significant, you basically remove that. Okay, and you end up with the one that the combination that you collected using a certain route. But this doesn't mean that you have tested all the different combinations. It's just you started with 1 and 2 and 3 and so on. So that's called stepwise modeling. You add one variable at a time and see if it's significant, and you leave it. If it is, you remove it if it's not. There's an issue here whenever you add 2 that are correlated. So let's say that you have one of the examples would be heat, the temperature, and ice cream sales, for instance. So temperature could be associated with humidity, for instance. So you have humidity and you have temperature in your data set as 2 independent variables, but they might be correlated. And that is not good. So if you add them, the R square will increase and both will be significant. So you want to detect them. This is called the multi-collinearity. So they are correlated and they represent pretty much the same impact on the dependent variable. And you want to get rid of that. We use what we call value inflation factor. I'm going to show you a quick example on my end, but there are sure other examples that can be shown. This is the final exam, if you wonder. Let me see here. I want to pull that up. And I believe it's chapter 15. Yes, it's this one. No, that's the example. And should have it here. Yeah. Multi-collinearity example. So these are sales activations for a subscription. That's basically sales. We have experience for that salesperson, gender, we have performance, and we have age, okay? And their salary. So we want to predict the number of activations given all these variables. So we want to know the perfect combination of these variables. We are going to try all the combinations here. So first, we're starting with activation and then trying to predict activation. And we have this is called value inflation factor, VIF. What is this and how is it calculated? It's 1 divided by 1 minus r squared. So you are going to use all the independent variables and make one as a dependent variable, one at a time. So in this case, we had the gender as our independent variable, or maybe the salary, I forgot. But we made it, for each time you want to make that, and if you get for any of this, you get a value inflation factor greater than 5, that's an indication of multicollinearity. So here we used x3, and x3 was here 1, 2, 3, I think it was performance. So we made performance as our dependent variable, and the others were independent variable, and we got a value inflation factor as high. Basically, what we do is by making each independent variable a dependent variable one time, you can detect the correlation with which variable. And there, if we have this VIF as high, you can actually get rid of performance. We don't need it because we're capturing it by one of these variables. If we get a value inflation factor that is greater than 5. I'm going to pause a little bit and give you time to think and ask me questions.
Doctor, here performance is a dependent variable, and the
So
value inflation factor is high because there is another factor. There's another variable there that whenever the performance goes up, it goes up as well, right?
yeah. Yes, exactly.
Okay,
So
okay.
the original model is this. So activation is the original dependent variable, and all of these right here are the independent variables, okay? Now, to check that they don't have multicollinearity between them, we choose one at a time. So starting with gender, for instance, here we started with experience. I think that here we started with experience and then we made experience, as you can see here. We made experience as the dependent variable, and the other was gender, performance, age, and salary as independent. The value inflation factor that we got was less than 5. That looks good. It doesn't matter. This variable here is not correlated with any of these variables. Then we move to the next. We made gender as our dependent variable, and the others were independent variable. And in this case, if we look here, experience, performance, age, and salary. Again, this was less than 5. 1 divided by 1 minus r squared. There's no indication of multicollinearity caused by gender. Now, when we move to performance, there we started to see a high number here, which means that performance is potentially correlated with one of these variables. And the question would be, should we get rid of performance or should we get rid of some other variables? We should continue the test for all these values, and then once we get a number that is high like this, we are going to check that in a table. So if you look at the table here, we can see performance and salary. This is just a summary of all the value inflation factors of all these combinations. And we can see that salary and performance are high. To be sure, we basically in this case, we removed both performance and salary, right? And we made each of these a dependent variable, the remaining independent variables. Each of them, we made them a dependent variable one at a time to check that the value inflation factors are all good. And we did that in this case, and we got that, well, actually, all of them were okay. So if we get rid of performance and salary, we're left with a model that is not, or that doesn't have a multicollinearity according to this value inflation factor calculation. Any thoughts?
Yeah, doctor, it's clear. Because
Clear?
multicollinearity affects the final.
It's a bad thing, yeah. And you have two things capturing the same value. You're creating what we call noise to the data. So you have data that can be misleading.
What if we put only one of them? So
You
if we remove
can,
salary, performance wouldn't have a high inflation factor, right?
that's a good question. Actually, you would do it one at a time. But just for the sake of simplification in this course, you just get rid of that cancer. You just remove it.
Okay.
But practically, I would do this. Actually, when you do this best subset that I'm going to talk about, you check each single combination, and you see the best one, the one that generates the highest R-adjusted square, and it's all significant and all of that. All right, what do we have left here? Yes.
So doctor, the value of 5 is like a rule. It shouldn't be higher than 5.
Yeah,
It's well known.
that's I mean, if it's higher, that's a strong indication of correlation.
Okay.
All right. Now, examples, we talked about temperature. That's the value inflation factor. We talked about it. We had this example. I showed you that already. Now, the stepwise, as I told you earlier, I'm just going to repeat it. If you have several factors, you decide which of the remaining independent variables you need to include to the final regression model. That's the goal. This is the stepwise strategy for modeling. So you start with the one, each one, and you keep the one that is significant and it has no issues. And these are the questions. Well, start first, select the variable, highest correlation with the dependent variable. And then now correlation with a dependent variable, that's good. Correlation between independent variables, that's what we don't want, right? Just to clarify this, very, very different. These are two extremely different purposes. Statistically significant, yes, then it enters the model. And then the next variable, the one that explain the unexplained variation. So part of what was unexplained by the R square, you add that and see if the adjusted R square is going to increase. and then ask the same question. Is it statistically significant? Yes, then it enters the model. And if it's not, then you remove it from the model and test the next one and so on. Now, this way does not test all the combinations because what you removed could be actually relevant, but in a different combination. That's why stepwise is actually applicable when we have a large number of variables, independent variables. But it's not the best. It's not exhaustive. It's not comprehensive. And this is how you were supposed, or I was supposed to show you how to use that using pH stat. There are ways to choose a best subset or stepwise to generate the values, and you get all the results from there for each combination of variables. So it's going to tell you experience gender is going to be to generate this R adjusted square, adjusted R square. Experience gender performance. It's going to test all the combinations. If you have the best subsets, that's when you test every single combination. So all of them separately, alone, and then all of them with all other variables. The downside of best subset strategy is that if you have 7 or more, it's kind of impossible. If you do that on Excel, Excel is going to freeze and it's not going to do anything because that requires a lot of capacity to do. It generates too many sheets that Excel cannot take, basically. Okay. If you use Python, that's not a big deal, but that's a different course, different level.
Okay, so doctor, we do it like we do that test depending on how many variables we got. So it doesn't do them like all at once, right? We have to exclude the dependent variable each and every time. So in this
For
example,
the
we
value inflation factors, you mean, or for
no
this?
pH stat.
So pH stat does not look into VIF.
Yeah, VIF we have to calculate it on our own. We have to 1
Yeah.
over 1
So
minus
this is
the.
like here, don't include celery since we excluded it due to VIF. So we do that first, the multicollinearity. We do the check of the multicollinearity first. And then after that, you start building your model. And
Yeah,
then
I know.
when you build the model, now the question is, when celery was excluded, right?
Yes.
Now the question is, do we include experience and gender, or experience alone, or gender and performance? I mean, what combination is the best combination that can explain the variation of activations? And that will basically depend on the significance, and it will depend on the R square, adjusted R square.
Yeah.
All right.
So doctor, yeah, but
Mhm.
in the example earlier, when you opened the Excel,
Yeah.
we did it like we put an independent variable as the dependent variable
Yes.
each
Yes.
at once, right at a time.
Yeah.
So we do that using the pH stat or the normal regression.
No, that's not used using pH stat. That's used manually.
Okay, okay.
So if you have 7 variables, let's say, you're going to have 7 independent variables. You're going to have 7 tests of VIFs and see if all the 7 VIFs can work or are less than, generate a VIF of less than 5.
Okay, so what does the pH stat like add in does to the
It
what does
does
it do here?
it does the modeling, so the stepwise regression and the best subset, just to see which, you know what modeling means here in this case?
Yeah, the tables that we have on the right, like the
No,
coefficient, standard error,
how many variables should be included? So instead of you trying the how many if activation and having experience as the independent variable, and then generate that table, and then generate another table with activation and gender alone, and another table with performance, and another
Oh,
table with age, and then you want to try with experience and gender. That's another combination. Okay. So how many
okay,
combinations do you have? A lot, right? So instead of doing that, phstat would do that with a single click, depending on the strategy. If you say stepwise regression, it's going to do the stepwise strategy. If it's the best subset, which is basically what you want to use phstat for, it basically tests every single combination, and it gives you a table of summary showing the highest, showing all the results, including the adjusted R square.
Okay.
So you basically see, okay, I mean, this is a question for all of you guys. If you have two models, one of them has 3 variables and the other has 4 variables, independent variables, and both result in the adjusted R square, the same adjusted R square, which one would you choose? The one that has more or less variables?
More, right? The more we have, the better. We try
So
different.
let me rephrase this question. You are supposed to collect data about something to predict it, right? Demand, let's say. You want to predict demand. And what you're saying here, I need to collect data for 4 variables that will generate the same accuracy for forecasting as collecting data for 3 variables. Which one is wiser?
Minimum, the better. The
The
minimum,
one
the
that
better.
has fewer number of
Yes.
variables. I mean, basically what you're saying, I can be accurate with less number of variables. I can explain the variation with less number of variables. Okay. So it's always if you have a choice between 2 models, you always choose the one that has lower if they are, let's say roughly the same. So we talked about the disadvantage of stepwise. It's not exhaustive. Not all possible combinations are used. For best subset, it examines all the combinations, and you can use phstat. I mean, I was supposed to actually show you how to do that using phstat. I'm going to resolve that issue and come back to you later. Otherwise, it's not going to be part of the final exam anyways. Yes. But theoretically, you might be asked about it. Other selection methods. Yeah, we have stepwise called forward selection. Forward selection method would be something like you start with one. Once you decide that a specific independent variable should enter a model, it never leaves. So it will get stuck there. So if salary is significant and it generates high explanation for the variation, so a high adjusted R square, you just leave it. It never leaves the model, and you keep adding on top of it. So once any independent variable enters, that's called the forward selection. There's also a backward selection, and that's you start with all the variables. If you find one of the variables not significant, you actually remove that from the system, from the model. And once it leaves the model, it never comes back, and you regenerate the table again. So you may start with all the variables and remove, and then reduce it and remove and so on, or do the other way around. You add, and if it's significant, you keep it and you build on top of it.
So, doctor, which one is like more effective? Like, which one does?
What more effective? How it's not effective. Effective is a question of how many independent variables you have. So in all the for my clients and all the projects that I delivered personally as like a part of my business, I would say that whenever I have a chance to use best subsets, I will do that. No question. But in one of the projects, I had like probably over 25 independent variables.
Oof.
And I used Python for that. And Python will still use best subset for it. So I would say best subset, if you can use it, even using programming, that would be the best option. Otherwise, if you're limited by resources, go for stepwise.
So stepwise is less accurate, but it does it all at once, and
It helps. It gives you if you have more than 7 independent variables, yes, use stepwise
Stepwise.
regression. It will give you good results anyway. But if you want to be 100% sure, and if you're working with a big manufacturer or a big client, then you have to use advanced analytics for it. But there we get to machine learning, basically. From this point, we get to machine learning. And do you remember any of these? This is the last part. It's repeated from the previous chapter.
Yes. If we see like a trend of the points going outwards, or we shouldn't like
Yeah, this
accept
is
them, or
basically the final check to see if regression analysis and all the values, coefficients, all the variables in the system or in the model, they are all significant, they're all good. You have to check what we call residual plots. So these differences are tilted horizontally, and you see them from this perspective. So if the residuals have a constant variance, as you can see here, so they revolve around a kind of the range, and there is no pattern that you can see, that's going to be check. Residuals follow a normal distribution probability. So the way they are distributed follow a normal distribution, or can be fitted into a normal distribution curve. That's also another check. Residuals are independent of one another. So you can't say that, well, if this increases, the other one increases. Again, it's about the pattern. If we see a pattern, then there's some sort of dependency, which is bad. Linear relationships are also assumed between the independent variables and dependent variables. So if this is not a linear relationship, then we have to think about polynomial relationship. We can do that. We can generate a curve that looks like, let's say, the second degree, or any type of polynomial distribution that can fit the data. But for this kind of analysis, regression analysis, I would say that linear should be assumed, and it should the data should show that some sort of linearity at least. And with that, recap, what should we do? Going back to the beginning of this chapter, first, check the multi-collinearity. We're using VIF. And then proceed to step 2 once you get rid of all the variables that generate VIF that's greater than 5. Then, if you have more than 7 variables, use the stepwise. Otherwise, if you have less, basically just use the best subset. And the best subset will give you all the options, all the combinations, and then from there, you check a model that has the highest adjusted R-square, and basically that's going to be the highest that has all the independent variables as significant. If there's no significant, or a variable that is not significant, it has to be removed from that model. And with the best subset, we're going to see all of them at least. All right. And then, yes, basically the one that generates the highest adjusted R-square, that's the best model. If all the components are checked and there are the one that has the fewest number of independent variables that generate the highest adjusted R-square, that's the ideal choice. We want less variables. We don't want to collect more data. We want to collect less data. And then we examine the residual plots and make sure that they are completely random and there are no patterns and they follow the normal distribution. This was it. This is the final, and this is thank you so much in Swedish. Tack så mycket. I didn't bother to ask if if all went well. It was so fast, but at least it's an introduction. As you could see, it's mostly Excel.
Doctor,
So this yeah, please.
this is all the chapter 15?
This is all chapter 15. Yes.
Oh, perfect. Okay.
It doesn't look like it's much, right?
Yeah, but it is actually. It doesn't
Yes.
look, but it does.
Yeah. One last part that you have to watch, and I told you about, I'm just
The
repeating.
video?
It's the video.
The
So the
doctor,
video would show you, I have it right here. It will show you the question, one of the questions that could be part of the. So if you will see how you can with 3 variables, for instance, in this case, two variables, two independent variables, how you can generate a confidence interval and prediction interval that that are correct. It's not easy. Okay, just watch it carefully and try to understand the logic of that.
Okay, doctor, I just have one question about this topic, the
Yes.
confidence level. So, in order to generate a confidence interval, do we also need to do what we did today, like the p stat and
No,
VIFs
no,
and everything, or is it
that's
like
separate. That's
it's a
separate.
separate concept? Okay.
So confidence interval and prediction interval are concerning an estimate. So after you generate let's say that you have a regression model that you rely on, that you like, and that passed all the tests, okay? What I showed you in this chapter is how you would do it professionally. Like if you are a regression modeler, and you want to do it for a client, this is the due diligence that you have to do. But the questions that you're going to get in the exam are going to be specific and limited. Okay. It's going to ask you, well, given this regression model, estimate the price of a car that has gone this much of miles and that is 10 years old. And you generate first that estimate. And then it will ask you, well, how confident we want to be a little bit more confident. So include a confidence interval and include a prediction interval around that specific estimate. And that's how you
Okay.
get it. So it's not a separate topic. It's a separate question for a single specific particular
Okay. Okay.
estimate.
Okay. Okay. Okay.
Mhm.
doctor,
Yes.
doctor, since the pH stat is not working, are we going to be able like to do the things, the steps further? Because it's protected currently. So
So I understand that this, please don't get, don't require us to do any questions that
Don't
needs
include pH stat in the final.
Uh,
it would
let
be
me
great.
let me release you from this and say yes, it's not going to be required for any of the questions. I have the questions right here actually.
In the quiz folder.
I mean the quiz folder has all the questions that you might need. But I have it. You have 5 questions, and it's 30 points. It's 2 for one of the questions, 6, 6, 6, and 10.
10,
Yeah.
10.
You want to see what that is?
Yes.
That could be. So that could be, I think this is a multiple regression question. Yeah. You have 5 versions each. So that's going to be I'm not going to require you to use pH stat for now, but it's going to come back in business analytics. If you're going to take this course with me,
Inshallah.
I'm gonna need you to get it installed properly. But until that happens, at least you know that there is something that is called pH stat, and that can generate this stepwise and best subset modeling.
Okay. Doctor, I just have one question.
Mhm.
Will we have like a review session before the final, or
Do you want that or not?
Yes, yes, of course, doctor.
All right. So I have received some questions, and I'll address all the questions. If you might have, if you experience any difficulty. So I is asking, is there a class to review the final and solve the most important quiz folders? Oh, answering a quiz folder entirely, that's going to be challenging, but answering specific questions, that would be more feasible to do. So just if you have any question like this, just send that to me. I have received some questions that I'm going to go through, and I'll give you also some more information about the exam. And I'm going to record that, make that available for others to see, to be prepared for it. The exam is 90 minutes, so the challenge would be actually is in making sure your devices are fully charged. I know that the female section are going to be tested in classrooms, but in your case, I think it's going to be in a sport field or something. I'm not sure about it. But you have to think of a solution if you don't have that capacity. You have to have 90 minutes charged, or let's say fully charged means that you have, or you can use Excel and Moodle for 90 minutes. Yes, yes, it's going to be just the questions that you think that are important. Just send me the question that you're struggling with, and I'm going to answer that in a video step by step. Any other question?
no, doctor? All was clear.
Okay, okay. And with that being said, thank you so much. This was the last class in this course. And again, just do the 19 questions, understand them, and it's an easy 30. And then, yeah, and then from there, you get your grade. I have my best wishes for you guys, and I hope you all nail this question, this exam.
Thank you, doctor.
Thank you, and have a good one.
You too, doctor. See you soon.
Yeah, bye-bye.